physics, we are going to deal with physical quantities. Physics, we are going to deal with physical quantities. What is a physical quantity? Anything which we can measure is known as a physical quantity. Anything which can be measured. Okay, is known as a physical quantity. So we have two kinds of physical quantities to deal now in the IIT JEE curriculum, that is vectors and scalars. We have more than two, but then we don't have them in IIT JEE curriculum. So what is a vector? A physical quantity which has both direction and magnitude is known as a vector. And a scalar is just that physical quantity which has only magnitude. A few examples we'll take. For example, a vector, okay, and scalar. Examples like velocity, speed, time, scalar, acceleration is a vector, current, okay, so you have direction and magnitude, then it is known as a vector. And if you have just magnitude, then it is known as a scalar. For example, a person is going from A to B along east direction. This is east direction. Now, this person can reach from point A to point B in several ways. Let us see one of the ways. That is, let us say he is going up the hill, down the hill, and then he is going to B. So here he is going like this, then like this, and then like this. But then here the displacement of this person is given by just displacement. Shortest distance plus direction is from the initial point to initial position to final position. Then that vector is nothing but a displacement vector. Okay, that is the definition of displacement actually. Later in kinematics we'll learn this in detail, but right now the displacement of a person or a body is given by what? The shortest distance between initial and final point with the direction from initial position to final position. Okay, so always a vector always has to be accompanied with magnitude and direction. Then only the vector is completely described. Otherwise, the vector is not completely described. Okay, so vector here has more information than a scalar. For example, speed, you see speed, you try to see speed and velocity, the difference between speed and velocity. Suppose a bus moves with 70 kmph. Okay, 70 kilometers per hour. We haven't mentioned towards which direction, just the bus is moving with 70 kmph. Then that is the speed. But then if you say the bus moves with 70 kmph towards north, then we have a better description for the bus journey. That is 70 kmph it is moving with, and also along or towards north it is actually north. So you have more information hidden in a vector than a scalar. So a vector is obviously a better thing always than a scalar if possible to take a vector. Okay. Now we have, let us say, uh, how is a vector represented. Okay, let us try to understand how is a vector represented. A vector is always represented with a ray like this and a arrowhead. This is called head of the vector. This is called tail of the vector. It is represented by a line like this, and the length of this vector represents the magnitude of a vector. Represents magnitude of a vector. Okay. Now, what does it mean? Okay. For example, let us say I have a displacement of 1 kilometer towards north. Towards north. Person is moving for 1 kilometer towards north. Let us say it is represented by an arrow like this. Maybe this need not be 1 kilometer, but it should be proportional to 1 kilometer. Okay. There is, let us say, it is represented by 1 centimeter, for example. And let us say another lady is going by 1.5 kilometers towards north. Towards north. Then how is it represented by? It is represented by a bigger line, which is 1.5 times the previous line, like this. And on paper, it must be equal to 1.5 centimeters. So it should be to the scale actually, but strictly speaking, we don't draw it to the scale, not an issue. Okay, and a vector is represented by a small letter or a capital letter with a bar over it. Okay, bar over it. That is the representation of a vector. So this vector can be represented by a bar, or a velocity vector, let us say 5 meters per second towards east, is represented by v bar, or a displacement vector 2 kilometers towards east is represented by, let us say, s bar. So all the vectors are usually represented with a bar over the letter. Okay. Now we have different kinds of vectors. One of them is unit vector and null vector and opposite vectors. Opposite vector. Okay. So let us see one by one each one of them. Okay. So first let us see unit vector. This is one of the very important things to learn. Unit vector. Okay, so let us say a vector is represented by a bar like this. Okay, vector is like that. Then a unit vector means, first of all, the definition of unit vector is what? Unit vector is a vector which has magnitude 1. The magnitude of a unit vector is 1. Unity. So what does it mean? So a unit vector along a bar is represented by a cap. So what does it mean? Let us assume that the magnitude of this a bar is 10 units. Then it means that if you, a cap will be in this direction, like this. Direction of a cap is same as a bar. Okay. So if you draw a unit vector a bar like this, a cap like this, then 10 such a caps is nothing but a bar. So how do you write like this? How do you write this? A bar can be written as 10 times a cap. Or you can also write a bar as mod of a times a cap. Means A cap is a unit vector which has same direction as A bar. So therefore, direction is taken care by this A cap and the magnitude is taken by mod A. So always a vector can be written like this. Or you can say B bar can be written as mod B times B cap. Okay. Now let us see standard unit vectors. Standard unit vectors. Usually there are three directions we talk about: X, Y, and Z. Coordinate system is always divided into three coordinates like this. And it is customary thing that people have assumed that a unit vector along x-axis is represented by I cap, and along y it is represented by j cap, and along z it is represented by k cap. So for example, a vector is like this in this direction, having 15 units magnitude. Okay, so this is in what direction? East direction, that is, or along x direction, x direction. Then this vector, let us assume that this is z bar. Then z bar is represented as 15 times I cap. Isn't it easy to represent a vector like this? So it means that z has a magnitude of 15 units along x direction. Similar way, you can always write any other vector like this. For example, another vector is along y direction having 10 units. And it is represented by, let us say, B bar. So B bar can be written as 10 j cap. Okay. So this is how you represent vectors. Now, how to add to vectors? Addition of vectors. Okay. Addition of vectors. Suppose you have a block on a table. You are putting a 2 newtons force like this and a 4 newtons force like this. Then we can definitely say that there is a net force of 6 newtons towards east. That's easy to do. But what if the same block is there on a table, and this time you have a 2 newtons force like that and a 4 newtons force like this? How do you add this? Now that's a question to be answered. So that question we are going to answer in the coming slide. Okay. The ball was moving at 3 meters per second, and then with respect to this person who is in the pipe and fixed to the pipe, the ball was moving at 3 meters per second, and the pipe itself is moving at 4 meters per second. The pipe itself is moving at 4 meters per second. So after some time, what can you expect? This pipe will be somewhere here, and the red dot we have drawn here is somewhere here, and the ball is here somewhere. This distance is 3 meters, and whereas from here to here the distance is 4 meters. And you can declare that the ball's velocity with respect to the ground is 7 meters per second. Not an issue. Okay, that's easy to do. So here we have added two velocities, that is pipe's velocity with respect to ground we have added to the ball's velocity with respect to the pipe. So we have got the ball's velocity with respect to the ground. So this is what we have done in this example. Now let us assume same pipe is present and a ball again, and you have a red dot here, and now the pipe is moving upwards with 4 meters per second, and the ball is moving with 3 meter per second inside the pipe with respect to the pipe. Now what would happen after some time? The pipe will appear here somewhere, the pipe will reach here somewhere, and this red dot will appear here somewhere, and you can see the ball. The ball was supposed to be here, but the ball will be here. You can see here, in 1 second, the ball will be moving by how much is the question we need to answer. The ball inside the pipe in 1 second will move by 3 meters, whereas the pipe itself is going to move by 4 meters upwards. Now the net movement of the ball in 1 second will be what? This is the net movement. This is the direction in which, this is the initial position of the ball, this is the final position of the ball. So the ball has moved in this direction as mentioned here by how much? 5 meters. It has moved by 5 meters. So now if you want to find the velocity of the ball, this is speed of the ball. 5 meter per second is what? Speed of the ball. In 1 second it has covered this much displacement. So if you want to find velocity of the ball, then what would be that? Because 5 meter per second is just the speed. It is just giving you the magnitude. Now we are supposed to find the angle this vector makes with one of the vectors, which we already know. That is, let us say with east. This is east, let us say. Then with east, you are supposed to find this angle. If you can find this angle, you know for sure that at what angle, in what direction this vector is pointing. So once you know this angle, you are completely sure of this vector. That is, you know the direction as well as magnitude. And that is the complete description of a vector, when you know magnitude as well as direction. So here, how to find this angle theta? That's very simple, because this length is 4 meters and this length is 3 meters. And therefore, tan theta is 4 by 3. Okay. So to be more precise, theta is actually 53 degrees. Later you can check the trigonometric tables if you need. So here it was easy. Now this vector is known as the resultant vector R bar, and which is equal to A bar plus B bar, where A bar is this, let us say, the velocity of the ball inside the pipe, and B bar is this, let us say, this is velocity of the pipe itself. So now the same way we are going to see one more case. Let us say you have a pipe and you have a ball inside the pipe, and this ball is moving with 3 meter per second inside the pipe, and this pipe itself is moving with 4 meter per second like this. And after some time you can find this pipe here. Sorry. After some time you can find this pipe here, isn't it? And this red dot will appear here, and inside the pipe, the ball will move by 3 meters, and the pipe itself has moved by 4 meters like this. So the net movement of the ball is like this. This is the net movement of the ball. So this is the displacement vector. So with respect to the ground, the ball has covered this much displacement. With respect to the pipe, the ball has covered this much displacement. With respect to the ground, the pipe has covered this much displacement. So now we are supposed to find the ball's movement with respect to ground. So therefore, we are supposed to find this length. If you can find this length, that would be giving you the net displacement of the ball. For that to know, we should know at what angle the pipe is moving. So this angle, let us say, is 60 degrees. That has to be given. So the velocity of the pipe is given now. Velocity of the rod ball you already know. So therefore, we are now going to find this length of this line and the angle it makes with one of the vectors. So alpha, let us say. So how do you do that? Let us try to see. That's very simple because you know Pythagoras theorem. So let us use the things which we know and try to finish off this point. So if you drop a perpendicular here like this length, first of all, this angle is 60 degrees. And you know this length is 4 meters. In 1 second, the pipe is going to move by 4 meters. So if that is 4 meters and this is 60 degrees, this is, let us say, X, and this is, let us say, Y. This is Y, and this is, let us say, X. Then X by 4 is equal to tan 60, sorry, cos 60. And Y by 4 is sine 60, isn't it? So now you know X is equal to 2 meters and Y is equal to 2 root 3 meters. Do the simplification, you'll understand that. Now let us say you have to find this length, isn't it? That length is a hypotenuse of this side and this side. So that would be called what? Root of 3 plus x whole square and plus 3 plus x whole square plus 2 root 3 whole square or y square. Y square. So that would give you what? Let us see. That would be equal to root 37. P plus x there, then you'll get the value as root 37. So this is the magnitude. That's the length of this. Okay. Now you are supposed to find an angle. That is alpha. So tan alpha is what? Tan alpha, you know, is y by 3 plus x. So that would be equal to what? 2 root 3 divided by 5. There is some value, you will get some value for this. And if you look into trigonometric tables, then you'll get some value for alpha. No issues. That you can just refer trigonometric tables. Or you can just check in a scientific calculator, not an issue. So this is how you actually find the length of this and this angle alpha, whichever you need. Now here, what did you do? You added two vectors. So what did you actually do? Mathematically, you actually found the diagonal lengths of a parallelogram. Diagonal length of a parallelogram. Or otherwise, you can also say that mathematically you have found the third side of this triangle. Either one of them is same. Finding the diagonal of this parallelogram or finding the third side of this triangle, both are same. Parallelogram law of addition or triangular law of addition, both are actually going to be used for the same thing and they represent the same thing. The only difference is in this two, when you want to add two vectors a bar and b bar, a bar and b bar, let us say a bar and b bar, then you are supposed to attach the tails of these two vectors in parallelogram law of addition. Whereas in a triangular law of addition, a bar and b bar are drawn such that head and tail are consequently drawn like this successively. Okay, so please remember the difference here. Here head comes before the tail here, whereas here two tails are joined. Here the diagonal is the one which is called resultant, and whereas here the third side is called the resultant. This is represented by a bar plus b bar. This is how you add the vectors. Now let us find the mathematical expressions for this. This is the angle we are going to find. You can find either this angle or you can also find this angle, doesn't matter, both mean the same. Okay, both mean the same, means alpha is not equal to beta, but then if you find the angle with one of the vectors which are given already, then that's enough. Your vector description is complete. Okay, so how do you do that? Let us see. Okay, let us see. Now you draw the perpendicular here, and this is mod A, and this is this angle should be given, angle within the vectors, that is theta. And in that case, this is x, let us say, this is y. X by a mod A is cos theta, and y by mod A is sin theta. So in that case, mod r will be equal to what? Mod r will be equal to mod of a bar plus b bar, that is the magnitude of addition of two vectors, is equal to root of mod A mod b plus x whole square plus y square. Just look at the Pythagoras theorem. We are just learning Pythagoras theorem. We are just applying Pythagoras theorem. So that would give you what? Let us see. That would give you mod b plus mod a cos theta. That is x is mod a cos theta whole square plus mod a sin theta whole square. So that will give you a root of mod a square plus mod b square plus 2 mod a mod b cos theta. That's it. And then tan alpha is again simple. That is equal to y divided by mod b plus x. Okay, y divided by mod b plus x. So this will give you the result as tan alpha is equal to mod a sin theta divided by mod b plus mod a cos theta. So we have determined alpha and we have determined the modulus of a bar plus b bar. That is, we know the magnitude, we know the angle with one of the vectors. So that completely describes a vector. So our addition of two vectors is complete. Okay, guys. So we will end with this. In the coming lectures, you are going to learn about subtraction of vectors and multiplication of vectors too. Okay.